Hey, hello everyone. How are you doing? Welcome back to 40 Days of JavaScript. And today we are at the day 29. A special session today because we will be talking about object oriented programming. We just finished our module 4 with asynchronous JavaScript and projects and starting with module 5. In module 5, we are going to get started with advanced JavaScript concepts. In the next 6 to 7 videos, we are going to cover through object-oriented programming concepts, a lot of hands-on using ES6 class, constructor functions, prototypes, prototype chain, and then we'll be diving into JavaScript modules. After that, we're going to talk about advanced data structure like maps, to weak map, weak set, and then of course we are going to do project using object-oriented programming concepts and everything that we learn in this module. It is going to be an awesome module for all of you because at the end, I am going to show you how to debug and fix real world bugs in JavaScript. I'm sure that you're going to love that. So if you don't want to miss it, please subscribe. I'm going to make a small change though in this particular order. I will be pulling it up in day 30. That means the next video. And then prototype and the prototype chain will go to day 31. The reason for this is today we are going to clarify a lot of concepts around object oriented programming. We're not going to write too much of code. But in the next session, we are going to do a lot of things which are pure hands on, project oriented, using the classes and the constructor function. And then we'll be talking about the prototypes, prototype chain, and everything. I think this particular sequence makes a lot of sense. So first three videos all about OOP, then modules, then advanced data structure, then going to do a project with OOP, and at last we are going to talk about the real world debugging challenges. Awesome things for you. So what are we going to cover today? We are going to start with objects. We have already taken a deep session about objects. You all know about objects, their constructs and everything. But we need to revisit objects once again because we're talking about object oriented programming. So, in the context of OOP, we'll be looking into objects. While looking into objects, we'll also learn what are classes. We'll also visit what are functions. My intention is not to go through their syntaxes and definition again. Rather, I want to relate a class to object to a function so that you know that why it makes sense and how are you going to use them in your actual programming together. Of course, the thing, how can you practically think of classes and objects? When you talk about object oriented programming, I think the power and the creativity of thinking through classes and the objects are very much required. That is where you also need to know what is object oriented programming and why object oriented programming is still important and relevant as a programming paradigm. Then we're going to talk about a few real world use cases of object oriented programming. This is where by this time, by the sixth point, I think you'll be very comfortable with OOP concepts, how to make use of it, where to apply, and how to think, basically thinking in OOP with all those. And finally, we are going to talk about five key object oriented programming principles. I'm sure like you would have heard about all these things already, either in your academics or later point in time you would have definitely learned about it, like abstractions, encapsulations, inheritance, polymorphism, compositions, all these things. We're going to talk about this. See, when you talk about object oriented programming and if you ask to people, I have seen them talking about four different things. Either they don't know what is object oriented programming. Second thing, they don't understand the principles of object oriented programming so well that they say that we don't know object oriented programming. Third thing, they know all this principle or they know what is object oriented programming, but they don't know how to apply it in the real world programming scenario. And the fourth one, people they know, but they never got a chance to apply it in the real world programming scenario. So after this module, I believe that you will be someone who will know OOP, who will know all the principles, who will know where to apply it, and of course we'll get an opportunity to apply it because we are going to do project. Okay, so that's the whole intention. So with all this, let us get started with what are objects, understanding of it. And another thing, in today's session, I am not going to code. I probably won't be writing any code in front of you. It is more about a theoretical session, and this is very important for you to do any hands-on in this module. So please pay attention, take notes. If doubts, ask questions. Let's start with what are objects. We're not getting into the syntax like, okay, objects gets created with the curly braces, it can have key and value pairs, all these things. We have learned all this syntactical thing. But think from the real world scenario. What is object? If you have to define what is an object, object represents real world entities. Okay, this is how you will be talking about, like, what is object? Object represent real world entities. What are those real world entities? It could be a car, could be a person, could be a bank account, could be anything. How object can be defined? If something can be described as a thing with some characteristics and behavior, then it can be turned into an object. I'll repeat this. If something can be described as a thing with characteristics and behavior, it can be turned into an object. So object will have characteristics and the behavior. What? Object will have characteristics and the behavior. The characteristics are also known as properties or attributes or state. Please note down with me. Okay, these things are pretty important. Characteristics are also known as properties or attributes or state. Behaviors are known as methods or actions. So these are different terms that people use in object oriented programming when they define object. Sometimes they say characteristics, sometimes they say properties, sometimes they say attributes, sometimes they say state. For behavior, sometimes they say action, they say methods. So you have to understand them. Now on my screen, you are able to see a car. Now car is something that I can describe this one as a thing, because car is a thing, of course. It has certain characteristics or the properties or the attributes or the state. What are those? It has a color, right? I can see the color is red. It has a model. Like, what is a car's model? It has a brand. It is BMW, Audi, Maruti, what it is. It can run on a speed, a maximum speed. So these are the things: number of wheels, number of headlights, number of bumpers, the type of windshield, how many seats are there inside. These are all characteristics, these are all attributes of this particular thing which we call as car. And then comes behavior or the methods or the actions. A car, you can start a car by push up a button or with a key. You can drive the car, you can press a brake to slow down, or you can stop the car. So the behavior of the car can be changed from start to drive to brake to stop. These are also the actions of this particular car. So hence I can tell the car is an object. Okay. This is how you will be thinking about object and relating it with the real world object. And this is the creativity I was talking about. You must have it when you're talking about object oriented programming. Let's take one more example. This is a person. A person, what are the characteristics it has? The person has a height, it has a name, it has an age, gender. There are different kind of characteristics or the properties that a person can have. What are the behaviors or the methods that a person can have? A person can eat, a person can sleep, a person can walk, a person can dance. So these are the different kind of behaviors, different kind of methods or the actions a person can have. It is also a thing. So I can turn this into an object in the object oriented programming. Let's take one more last example. Let's take an example of a bank account. What are the properties a bank account can have? It can have an account number. It's a unique account number using which you can identify an account. Your account can have a balance, right? You have this much money left. So these are the properties, state, and attributes of a thing called bank account. And what kind of behavior or the methods or the action that you can take on bank account? You can deposit money, you can withdraw money, you can check balance. All this thing you can do, isn't it? So those are the behaviors, those are the methods. And bank account is a thing, of course. So we can definitely consider bank account as an object as well. So when we talk about object oriented programming, you have to think about how you can model things from real world to your code. So it means that if I'm talking about a bank account, if I'm talking about a person, I'm talking about a car, if you have to solve any use case or any logic using car, person, bank account, or whatever it is, you have to think about how you model that in terms of an object in your code, so that that object will have certain properties of the state and it will have certain methods or actions. In our object session, we spoke about what is the method in object. Do you remember? The object can have properties. Properties are key value pair. Key can be string or a symbol. Value can be of any valid, legit JavaScript data types, including functions. Those properties whose value is a function, that particular function we call method. There also we spoke about properties and method. Right now we are trying to relate those properties and methods of an object with the real world thing. That's how you need to think in object oriented programming. So I hope it is clear what is an object at a very high level. If you ask anyone, can you define class in programming? The term or the word that you will hear again and again is called blueprint. Everyone will say that class is a blueprint. Let me try to make you understand what exactly the word blueprint means, because for many years I didn't understand the word blueprint at all. Blueprint, for example, blueprint of a house looks like this. If you want to ever construct a house, which is real pain, I know that constructing a house is not easy. But if you want to construct a house, you go to an architect, and the architect sits with you, and then they prepare a design based on your taste. For example, you want a master bedroom. Great. Coming out of the master bedroom, you want a sink over here, then you want a kitchen, then want a place where you can take food, a dining area maybe, then there might be a puja room, things like that. So they will design as per your need, and that particular design will be followed throughout to construct your house. So this design is a blueprint of your house. This is not the actual house. It defines how the house should look, how many rooms should be there, how many doors should be there, how many windows should be there, but it is not a house itself. It is just a plan. This is what a class is also. The best way to identify a class is it is a plan for creating something called object. By now, we know what is object. We know car is an object, person is an object, bank account is an object, a camera is an object. But those objects, a house, a camera, a person, or a bank account, would have got created from some plan or some blueprint. That plan or the blueprint is what we call class. We will see at actual how the class looks. ES6 JavaScript ECMAScript 6, it started the support of class, writing class in JavaScript. Before that, it was not possible to write classes in JavaScript. Everything we had to handle through functions and the objects. But now I can define the blueprint in the class in the programming language itself and create objects from that. There are many other languages like Java have been supporting this from the beginning, which is awesome. But in JavaScript, it came very late and it is very flexible. We're going to see a lot of it. But for now, theoretically, this is a blueprint. Now, if you have this as a blueprint, that means that from this, you can now create objects. Objects are the actual house that can be built using this particular plan. Something like a house like this. We applied this plan and built a house, though look like a ghost house, but still a house. Or maybe a house like this, a house covered with snow. Again, we have applied the same plan that, where is the kitchen, where is the bedroom, where is the dining room, etc. But still, between these two houses, there are some differences. For example, the color of this house and the color of this house is not same. The outside compound of this house and the outside compound is not same. But what the plan defined, that definitely there will be walls in the plan for the house, and then definitely there will be a compound in this house, but it didn't define what will be the color of that house in the plan. It just defined there will be wall and wall will be colored. There will be compound, but it didn't define how the compound will look like. It didn't define that how the painting of the windows will be there. It defined that there will be windows, right? So a plan will define that what are the attributes, what are the behavior that an object will have, but each object that will be creating from this class or following this plan will have the unique value for each of those attributes. For example, this house has a stone wall, this house has a wooden wall, but in the plan both the houses are having wall as a plan. This house, the color is yellowish, this house the color is beige. In the plan it is there that there will be wall and there will be color, but it doesn't define what color it will be, right? So that's why we can say that a class is a blueprint or the plan that each of the object will define by their own characteristic and create different instances of that particular plan. So whenever we have to create an object, first we will sit and try to figure out, okay, for this object we need these properties, we need this behavior, we have to define a blueprint or the plan for this object. So you will be defining a class, and from that class we'll be creating different objects. We'll be seeing all this thing in code, but for now this is what the theory behind it that you need to understand object oriented programming. So class and objects, we are done. Just remember, class is a blueprint, object is the thing that we create following or the using that blueprint. Okay, now what is function then? We know about class, we know about objects, but what is function? Okay, so I have a house, right? Inside the house, you're seeing lights over here. So there will be something to switch on this light, right? A switch, tuck, you put the lights on. That is a functionality that you have built inside this particular house. This house, the way the light setup is there, in this house, the way the light setup is there could be different. In this house, if at all in this ghost house light is there will be a switch to turn on the light by pushing the switch down or up. In this case, it could be a smart house. Like the moment to come inside, it will be enlightened. Both the houses are having light, but the way they function is different. So that is what a function is. A function is an action or the utility you can perform either in the house or outside the house, means in the object. So those are the methods. For example, for a car, what will be the function? Start, stop, break. For a person, eat, sleep, dance. For a house, switch on the light, switch off the light, turn on the geyser. These are the actions that will be performing through functions. So this is how a class, class to object, object to functions are defined and related. I hope this is crystal clear to you. Now, if this is clear to you, let us step into object oriented programming. Let us first understand what object oriented programming is. Imagine you are building a big city, of course, with software programming, computer programming, not like you're building city literally. Now, if you're building a big city, maybe you are doing a game application in building a city. Now, instead of writing a giant function, a big function to describe what this whole city is about, what the whole city should have, instead, won't you think in this way that a city can have houses, it can have cars, it can have people, it can have hospitals, it can have roads, and so many things, isn't it? So a city can have so many things. Now, if I just drill down into houses alone, just now we spoke, what houses can have? It can have roof, doors, windows, so many things. Similarly, for cars, it can have model, brand, color, wheels. We can keep going on, right? Similarly, the people can have what? Eyes, ears. Hospital can have bed. Roads, what can have width, height, destinations, etc. So it means to build a city, you have to now define that what are the characteristic or the properties that a city can have. Then you have to go inside those properties and define what are the further state or the properties that those properties can have. Maybe what are the behaviors that those properties can have. For example, a car can have a behavior like, you can start a car, stop a car, you can drive a car. A people can have a behavior like it can walk, it can eat. Hospitals can have its own behavior, roads can have its own behavior. So it means now you are thinking through objects. You are thinking with objects. Instead of writing a gigantic functions of code, now what you will be doing to build a city, you will be break the city into its properties and behavior, and then think about whether each properties can be broken further with its own properties and behavior. That means now you are thinking like objects or thinking through objects. It means you are thinking about object oriented programming. So my friend, object oriented programming is a programming paradigm or the programming concept. It is a way that you write code where you organize everything around objects. This is the exact example I have given. Here to design the city, I am now organizing everything around object. I'm creating an object for house, I'm creating an object for cars, I'll be creating an object for people, hospitals, roads. Thus a city is formed. But remember, building a house object, just building a car object, just building a people object, things won't be ending. You have to create relationship also between object. Who will have house? People will have house. Who will go to hospital? People will be going to hospital. Who will drive car? People will drive car. Who will walk on the road? People will walk on the road. Will you drive the car? You will be drive the car on roads. So you are now also creating the relationship between the objects. So this is what the object oriented programming, again the definition is a paradigm through which we can write code where we can organize everything in our code around objects just like it happened in real life. So anyone coming to you telling boss, I have this use case to build, I have to build this chatbot, I have to build this game, I have to build that. If you can think through breaking that thing down in terms of objects, can build the relationship between those objects, and then can write code to create them and establish relationship, you are actually working on object oriented programming. We know object is a bunch of properties and methods. Properties are nothing but the data that you hold for an object. How many roof, how many doors, how many windows is also called state. Behaviors are nothing but the things that you can do using that particular object. So instead of writing code as a long list of functions, you model real world things as objects in the object oriented programming. I hope this definition you're not going to forget. Did you like it? Please post a comment if you like this definition, if you will remember what object oriented programming from now. Let's talk about a few use cases so that you can also understand why object oriented programming is so important. You will be given the requirements by someone, whether a direct customer or your product manager or someone will give you the requirement. Once you get the requirement, your job will be to sit and then break the requirement into smaller pieces and then think through the objects, like what are the different objects or the entities that I can identify in this particular requirement, and what are the relationship between them. For example, if I talk about the game development use case, you can find plenty of objects like this. You will find players in the game, there will be like enemies, you will structure your gaming logic around this. Similarly, if I ask you to build an e-commerce website, what are the objects that you can think of? I'm sure you would have thought of at least one of them. You would have thought of users. Without users, there is no e-commerce. You would have thought about product. Without product, there is no e-commerce. You would have thought about cart, because user will buy the products, add to the cart, remove from the cart, then they will place the order. So each of these entities are the object. And do you see there is a relationship between them? User can choose the product, add to cart, from there they can give the order, like there is a relationship. So you will create the objects and you will establish the relationship. Let's take one more example. What about a mobile apps? Here you will think about components like screens, buttons, notifications, isn't it? Similarly, for a banking software, you will think through customers, account number, transactions, all these things. Let's take one more, like vehicle management systems. Here you will think through vehicles are objects, and it can have different types. Like a vehicle could be of type truck, could be bike, and it will also have some relationship among them. So these are few examples, only a very few examples, to let you know that when you get a requirement or the use case to develop from anyone, how you will be thinking through the objects and their relationship. So we have covered everything till here. What are objects? What are classes? What are functions? How can you practically think about classes and objects? What is object oriented programming? Why it is important? And the real world use cases of OOP. Now we are getting into one of the most crucial section of this video, which is about 5 key OOP principles. These principles, only as a jargon, they are difficult, but actually they are very simple. Let's crack them down with examples and with some diagrams so that you are never going to forget them as well. First, let's talk about abstraction. Hey, do you know what it is? I'm sure all of us know, right? This is nothing but a TV remote. What do we do? With this, we can switch on the TV, we can switch off the TV, we can change channel, we can increase volume, decrease volume, we can mark a channel as favorite. There are a lot of things we can do. Modern television, you can record and all these things using the remote itself. Now, while pressing the button for starting the TV, where pressing the button to record or switching off the TV, do you really bother how remote is doing that? You don't bother, right? As a user, your concern is only about that red button you see at the top for switching it off and on, and then probably this button to start recording, this button to change channel, this one, and this for volume, like that. You only care for that, and that's how it should be. This is what the abstraction is used for. With abstraction, you hide the internal complexities of a system, of how it works, and you only expose what's really necessary for the user to interact with. With the TV remote, exactly that's what happened. The TV remote is designed in such a way that how the signal processing is happening when you switch on, switch off, start recording, all these things are abstracted from you. It means that those are all internal details. You or me as a user has nothing to do with it. So these are all internal complexities of how a remote works is abstracted from us, and only things that are exposed are the necessary buttons that we should be interacting with. The definition of abstraction is exactly that. Abstraction is the process of hiding the internal complexities of a system and only exposing what's necessary for the user to interact with. I hope you will never forget if you remember the remote example in your mind. Now, why it is important? Because tomorrow in the session 30, when we are taking a use case, building a class from that object, and we have to think this is the use case where we have to use abstraction. That's how we will come to know when to apply a particular principle of OOP. But before that, you have to know what it is. That's what we're doing right now. So what are the characteristics of an abstraction? It only shows what is necessary, and you don't need to know how it works. You just know how to use it. Let's take one more example in little bit programmatic way, though we are not writing any code. This is my coffee machine. Okay, let's imagine this is my coffee machine. In this coffee machine, only thing I know as a user, or I should know as a user, that how to make coffee. So make coffee is a behavior of this particular coffee machine. This is the only thing should be exposed to me so that I can go click on certain buttons and it will make the coffee for me. But while making the coffee, there are a bunch of things that can happen inside. For example, the coffee machine has to know how many water tank it has. It has to know whether the heater is on or not. If that is the case, it will take the water and first it will do start boiling. After boiling the water, it will do brew with the coffee beans and then my coffee will be dispensed, right? Now, if I ask you, among all this water tank, your heater, your start boiling, brew, dispense, what are the properties of this coffee machine? And what are the methods or the actions of this coffee machine? I'm sure you will be able to answer that. Water tank is the property of a coffee machine because through which the coffee machine knows that how many water tank it has. So a water tank is a property whose value we can say is a number. Whether the heater on or not, it is another property, could be boolean. If it is true, it means it will say the coffee machine, hey, heater is on. Start boiling with the name itself, it sounds like a action or a method. So it is a method which will start boiling the water. Then it will do the brew. Brew means is getting the coffee powder and that boiling water. Maybe it has milk or something, and it will start creating that particular coffee. And once the coffee is done, it probably give a message saying that coffee is done. It might return a message. So it's a string. And then finally the coffee will be dispensed, so that you can hold a cup and you can get the coffee. So that also a method. So it means that coffee machine has two properties, okay, for our example sake, and it has three methods. With all these things together, what you get finally is a coffee. Okay, and this is the only thing that is exposed to the end user. That means it is something which is public. Otherwise, each of these things that we are talking about, I'm actually marking them with this minus. It means that these things are not accessible to the outside users. These are all internal to a coffee machine. Okay, so when I am talking about object oriented programming and its principle, there are ways that you can think through, depict, design, architect your solution. So if I'm talking about build a coffee machine software which will make the coffee, then you will be thinking through what are the different properties or the different methods that you can have. Of course, you have thought through. Then you'll be thinking through, do I really need to expose this brew function to my end user? Because end user is not brewing it, is the coffee machine needs to brew it. End user is not making the water hot, it's a coffee machine need to make the water hot. End user just need to make the coffee. So if I just expose one function called make coffee that user really care about, and if the make coffee can make use of all these functions internally, my job is done. That's why you have used abstraction here. You have abstracted out all start boiling, brew, dispense, everything, and expose just one make coffee for your end user. I hope you understand abstraction even from the code thought process wise. We are going to write code for all this thing in the next video. Will you be there? If you don't want to miss, don't forget to subscribe. I'm sure you will enjoy the upcoming videos as well. All right, so we all understand abstraction. Now there could be varieties, other analogies I can take. I can keep going entire day talking about abstraction. Washing machine. Washing machine, how it works. You put some powder and put the cloth and you hit just one button to the washing machine. Start. Once you do start, what happened in the washing machine? You start filling water, gets the detergent from the detergent chamber, mix it, he start rotating the drum, he start washing, then it drains the water. Does user needs to push the button for filling water, adding detergent, rotating the drum, draining the water? No. It's all happen internally. But these are all functionalities of the functions that are taken care by the washing machine. Only thing that washing machine exposed to the end user is the start wash functionality. All filling water, adding detergent, rotating the drum, draining the water, all abstracted away. So that's another example of abstraction. For example, a famous thing, car. When you drive a car, there are a lot of things happen, right? The engine gets started, then it move forward. So internally, a lot of things happen in the car. So why the car gets started and you are able to drive the car? Only thing that you press the drive button or the start button. Nowadays, all the cars are with the push button, right? You push, it gets start. But internally, there are a lot of things. You don't have to do each and individual thing manually. That's another example of abstraction. So I hope abstractions, we killed it. Now, next thing that we are going to get to is called encapsulation. Let's understand that. All right, I won't ask what it is because you know it's an ATM is written. What happened with an ATM machine? When you use an ATM, you insert your card, you enter the PIN, and you request money. Now, all the thing behind, like your balance, your transaction logging, your security checks, these are all this logic are hidden inside. You cannot, you must not, you should not manipulate what is going on inside the machine. Okay? The ATM bundles the data, which is like your account data, and some methods like withdraw and deposit. That's what you can do, right? And protects everything possible from the external tampering. That's what happened in the ATM machine. This is an example of encapsulation. Encapsulation, if you want to define it, it's a methodology through which you bundle the data and method. In the ATM case, the data is your account, method is the withdrawal, deposit, etc. To operate on the data means to operate on the account itself. Those methods get operate on the account itself as a single unit, which we will be defining through classes in future and restricting the direct access to any other component. This is what we call encapsulation. So if you think through the ATM machine perspective, the data is your account information and the methods are the deposit and the withdrawal. The method deposit and the withdrawal applies on your account number, but your data and everything is completely restricted. Nobody really can access it. If you want to think it through this diagram, let's talk about the bank account itself. Now, in the bank account, what are the properties that you can deal with? Some of the properties, for example, a balance. And then what are the different kind of actions that you will be dealing with? One is deposit. You will be depositing an amount. Then one could be withdraw. You will withdraw an amount. And there could be something called check balance, through which you can check the balance. So let's say a bank account has these properties and these methods. Of course, balance will be a number. We know a type number. Deposit, it's a function or the method, doesn't return anything. Withdraw, of course, doesn't return anything, let's say. And check balance, of course, it will return a number like how much money you have in your account. So these are the things, these are the properties and the methods that a bank account can have. Now, from the outside world, you cannot really access the balance property. Okay. Now, the balance property could be a private property. What is exposed to the outside deposit, withdraw, and check balance. And through this deposit, withdraw, and check balance only, you can do something with the balance. That means balance is a private property of your account object, and each of these methods are the public methods of your bank account object so that user can use this to do something with your balance property. This is the world of encapsulation. Now I know that as a newbie, you might be little bit confused now. Okay, abstraction is also about hiding something. Encapsulation is also look like hiding something. Then what is the difference between an abstraction and encapsulation? Believe me, this is a confusion that many developers have. So abstraction and encapsulation are very closely related and often confused, but they serve very different purposes in the object oriented programming. So the clear comparisons are in their purpose. The purpose of a washing machine is not to give you the functionality of rotating a drum or filling the water, is not to hide from you. It's because It doesn't want you to get bothered about doing so many things. It does hide all those things from you and expose one functionality like starting the machine, which in turn going to do all these things from you. So there is nothing about restricting. It is more about hiding the complexity. So whenever you talk about abstraction, the purpose of the abstraction is always about hiding complexity, not about restriction. But in case of encapsulation, it is always about restricting the direct access. That is the balance. I am here not restricting another functionality. I am here restricting a particular property that I intentionally don't want the outside world to access. If you have to do anything with it, you have to come through these methods. Okay. I hope this is very clear. The purpose is one is to hide the complexity. That means complexity of other functionalities by not exposing them. Another one to restrict the direct access of an internal value or of an internal state. That is what is encapsulation. Abstraction always focus on what a object does. Okay, abstraction always focus on what an object does. For example, driving a car, you don't know how the engine works, you just drive. Encapsulation always focuses on how the object protect itself. For example, car's engine is sealed, you can't change it unless you are a mechanic really, because you don't have access to it, correct? So this is the difference between abstraction and the encapsulation. Always go by the purpose. Abstraction hiding complexity, encapsulation is protecting a particular internal value or state. Abstraction hiding another complex functionalities. I hope this is clear with all these examples. So whenever you get confused, think about these examples. I think you will be rock solid with it. Okay, let's go to our next one, which is inheritance. That's a sweet family, isn't it? There is father, there is mother, there is brother, sister, and of course a dog. Though the dog is part of the family, but still it is not inheriting anything from the rest of the family member. But think about that boy and the girl. They are inheriting a lot from their parents. For example, it could be their eye colors. Do you see the boy's eye color is just same as his parents? The girl's hair, style of hair is similar to the mother's style of hair. So inheritance works in that way. Whenever you talk about inheritance, you can think about the family traits. A child inherits traits from their parents. Eye color, hair type, or even the habits that can be passed down. Who could be better example than us? If we look at ourselves, we can understand it even more. Okay, I am doing something like my mom, or I am doing something like my dad, right? It's something like that. But with all this, you as an individual will have your own characteristic that your father or mother may not have. That means while you are inheriting certain properties from your parents, you as a child can also have your own traits, or you override a trait that you got from your parents. The moral is the new generations can reuse or extend what parents have. That's always the case in the real life as well. That's what exactly inheritance also in object oriented programming. It allows one class to reuse the properties and methods from another class. You can think about if you have a class which is like a parent class, which you also call as base class. From there, you can inherit the properties and methods to the child class. We also call it a subclass to reduce the duplication and to promote reusability. We'll see all these things in action when we go for examples in the next session. But this is how it is at a very simplistic manner how the inheritance can be explained. Again, if I want to go with the diagram, let's say we have an entity called vehicle. Now, in every vehicle, you will have a provision to start and stop. That's basically going to start the engine or to stop the engine. Now there could be different types of vehicle exist. There could be car like this, or there could be a bus like this. But either it's a car or a bus, both car and bus are vehicles, isn't it? So it means car can inherit certain things from vehicle. At the same time, bus also can inherit certain things from vehicle. For example, if I define how an engine should be started or how an engine should be stopped in the vehicle, this functionality starting an engine, stopping an engine, car can inherit and reuse in itself without redefining it. Same thing the bus also can do. If the same start engine methodology, same stop engine methodology can be reused for car and bus, they don't have to define it again in them. They can just use it from their parent vehicle. At the same time, they can now add their own functionality. For example, a car you can drive, right? After starting the engine, you can drive. For bus, of course, you can drive, but along with that, you can also pick up, right? So it means that the car now, along with start engine, stop engine that is getting from the vehicle, it can add its own functionality drive. Bus also can have its own functionality called drive and pick up. At the same time, can leverage the functionalities defined in vehicle. So this is what is inheritance is about. Inheritance is always about reusing something from your parent, at the same time have the ability to add something of your own itself. Here car and bus both inherit start engine from vehicle, at the same time they have added their own functionalities as well. Real life you have bunch of such things, right? With the parents, with the vehicle, with all this car, bus, you have a lot of such examples of inheritance. The main points that you have to remember about inheritance is like the code reusability. I'm now not duplicating the same code in both car and buses, so I'm reusing. This helps me avoiding rewriting any kind of shared logic, which is also a principle in design principle. Is called DRY or dry. It maintains a hierarchy, and this is where there is a very famous term I want you to remember is called is a come into picture. Here we say that car is a vehicle, bus is a vehicle. That's the reason it's a hierarchy with is a. It is of course having the extensibility. For example, here car not only getting the start engine, stop engine, it can also extend this functionality using one more function called drive. So I hope it is clear. Inheritance is clear to you. Let's go to the next one, which is polymorphism. No, I'm not asking you to run. What is run? We all know. But think about it. This same word, now, if I talk about few more things or few more context, you will see this run thing completely changed. The meaning of the run itself changed. When I say run for a person or a human, what you can imagine? A person is running means is mostly the person is doing physical activity, which most of us ignore. We should do run. Now, if I say run in the context of a business, okay, it's no more physical activity. It's about how a business operates, how you run a business. Correct? Same thing if I tell in the context of a program. Now it is no more operating, no more physical activity. It is all about executing a program. Correct, na? So now, based on the context, the same thing having different meaning. This is what exactly polymorphism is. Same action, same method, same command, but different behavior based on the context. Understood? These are very, very simple way that I could explain to you. I cannot really explain much more simpler way. I hope if you're taking notes, you're writing these things, scratching on the paper with your pen, you are never going to forget each of these things. So I hope you understand. There's the same method, same action, same command, but behaves differently in different context. So how do you define? What is the actual definition of a polymorphism? Polymorphism means different forms, many forms. Actually, it allows the object of different classes to be treated as if they are the same type but behave differently. For example, we took the run as an example. Like based on a particular context, it is behaving in a way. Based on another context, it is behaving in a way. We told a class is a blueprint. For example, if we take a class of a person, when a person running, it means physical exercise. Class is a business. When business running, we are operating. Class is a program. When program running, we are executing. Okay, so we are now able to relate the definition, the bookish classical definition, to actual example that we have taken. Where exactly polymorphism helps? It definitely helps you to be more flexible with your coding. Clean code, you don't have to really define different methods for different context. You have only one method but doing different job for different context. Do you want to understand this thing again with a diagram? Yeah, let's do it with a simplistic diagram. Let's take an employee class which has work as a public function. Employees work, we all know, right? Now there could be different kind of employees in an organization. Correct? One could be a developer like us who also work. What developer does, they're supposed to code. And there could be another type of employee, let's say designer, who are also supposed to do work. What they're supposed to do, they're supposed to design. Now, of course, the developer class can be inherited from employee. The designer class also can be inherited from the employee, only because both developer and designer is in the easy relationship with an employee. Developer is an employee, designer is an employee. Employee will have something called employee ID. Every developer will also have employee ID. Employee will have the email. Every developer will have email. Employee will have work. Every developer will have work. Same goes for designer. But on top of that, a particular developer might have something extra, right? A developer might have something called JavaScript skill, which a designer may not have. A designer may have something called a Figma skill, which a developer may not have, right? So they will have something of their own also, that we have learned from the inheritance already. Now, polymorphism is to extend the inheritance further, where each of these children have the ability to override the method that is there in the parent and give a completely different definition from each other. In case of developer, when I say developer work, it actually code. In case of designer, when I say designer work, it's actually design. There could be another class tomorrow, subclass or the child class, which is a tester, which test. So calling the work method on employee runs a different version based on whether employee is a developer or employee is a designer. This is what is polymorphism theoretically, is a way a same action or command produce different behavior based on under which context they are running. This is what it is in polymorphism, nothing beyond that. Believe me, when we are going to see each of this thing in code in the next session, you are going to relate them like anything. But right now, this theory is very important. If you are not writing it down as I'm saying, if you are not trying to understand each of these things very well, I think the next session is going to be a bit difficult for you. So please understand, these are really, really easy. Understand from the real life example is going to be cakewalk for you. Okay, let's move to the next one. I hope the last one, that is composition. Let's take the example of the car. Not exactly like the car. Let's talk about building a car. Let's say you are an engineer, automobile engineer who builds a car. Now, once you try to build a car, what are the thing you will think to compose together? What are those parts that you will bring together to build the car? You will compose engine, wheels, seats, lights, bumpers, all these things. So you are composing certain parts together to create something which is a whole thing like a car. So each part can work independently has its own role. For example, an engine is having its own role. You can fit that engine to a car, you can fit the engine to a bus, you can fit the engine somewhere else. A wheel, it can be rotated and it can move from one place to another place. You can put it in the car, you can put it in the cycle, you can put it in the bus. Seats, you can put it on the sofa at your home, you can put inside the car, you can put anywhere else. Lights, you can put on the street, you can put inside the car. So each of these things, engine, wheels, seats, lights, they work independently and has their own role. But when you compose them to form an object, you can do that and give different kind of attributes and the values to that particular object. So this is what the funda of a composition. Composition is like when you are bringing different parts which can independently play their role, have their own existence. You bring them together to build something which is bigger. This is what is called composition. Another attribute of the composition is like you can replace a part without changing the whole system. For example, let's say the music system of a car. The music system can really run independently somewhere also. If it has the power, if it has the Bluetooth connection, it will work. It works inside the car also. So car has a music system. Now you can take out the music system without changing the entire car, right? So in composition, while you are taking all the parts to build the whole, you can replace any part without changing the whole system. This is what the composition is. So if you have to define composition, so composition is a design principle where you think that inheritance might not work. For example, taking from the parents to child and adding more functions to child may not be the use case. Rather, it's a design principle where one class can contain or compose the things from another object of another class to reuse the functionality instead of inheriting. Okay, so when you again get a use case like building a city, and in the city has so many things, you establishing the relationship between those things, you have to determine whether you are going to go with the object oriented programming principle like inheritance or another design principle like composition. So that's why when we are discussing about object oriented programming and its fundamental four principles that we have already discussed, like abstraction, encapsulation, inheritance, and polymorphism, we have to learn about this particular design principle composition as well, because you have to take a call, you are going for inheritance or you're going for composition. We are seeing a lot of this when we are building the project towards the end of this module. Stay with me, you are not going to lose anything, you're only going to gain. So whenever we have to solve a problem, we should not just inherit for reuse, we can also do composition for reuse. When we have learned that inheritance is always about is a, composition is always about has a. We always say car has a wheel, car has an engine, car has a music system. We always say like that. We don't say car is a music system. Never. Correct, na? Car is a vehicle which has a music system. So in this English sentence itself, you know that in your programming, you can combine both inheritance and composition together. You can create something like a car which can inherit from something called vehicle, can reuse some of the methods like start engine from vehicle to class, and can have wheels, can have music system. So that's how you have to think where you have to use inheritance and where you have to use composition, is a versus has a. There are plenty of other examples. For example, a juice blender is not a motor. A juice blender has a motor. It has a container. Correct? Na? All inside. So things like that. So I hope this is clear to you. I mean, I hope that you're liking understanding all these concepts together that we are talking about. Before I end, let me do a quick recap about all these five principles that we spoke about. So, what is abstraction? Let me write it here. Abstraction hide complexity. It exposes an interface through which you can only access those exposed functionality. Example, remote control, start, stop, record, etc. You don't know the internal functionality. You don't have to know, basically. Those are the internal functionality. What is encapsulation? Encapsulations bundles the data and is protect the state, like your bank balance. It is not that you don't have to know. You are not supposed to know. You must not know. They don't want to expose the balance directly. You have to always go through some methods like withdraw, check balance, or deposit to do anything with the balance. Remember, inheritance, share the logic across classes. You will have a parent class, child class. Child can inherit things from the parent, also can add their own traits into it. Polymorphism, along with inheritance, what you do for the same method or the same actions, you give different behaviors based on the context. We know designer and developers both are employees, both work, but what kind of work they do, it completely depending on their context. Again, they can inherit the work from the employee parent as well, right? So it works with inheritance. Composition, build by combining the parts, combining the units, and then you build the whole. We know that. So these are the things, guys. I feel super happy, very, very honestly, like teaching you all these things, of course, in the possible simplest manner that I could. I want to know if it was helpful to you. If you are till here in this video, that means you have that eagerness to learn further. If you are till here, can you please post a comment saying that if you are here? I want to know like how many such comments I get in this video. And in the next video, everything that you learn theoretically over here, we are going to do hands-on by learning 6 classes, by learning the constructor function, which you have already learned, to make use of it in terms of OOP, and then to do something very, very useful and helpful. If you are skipping all these things and going for hands-on coding over there, I think it's of not much use, because your creative thinking about object-oriented programming is supposed to come from this session. Please find the task that I have provided in this particular module. You have to go to tapaScript GitHub. Make sure you give a follow. Go to repositories, 40 days of JavaScript. Come to day 29. Once the video published, you will get day 29. Inside day 29, you will find a task.md file and your task will be there. Make sure you complete the task and you post the task on our Discord. And if you want to discuss anything with community, you can always come to general of 40 days of JavaScript. Start posting your questions. Someone from the community, either me or anybody else, is definitely going to help you out. So guys, let's do rest of it also of this module. Please subscribe, like, comment on this video, share about it with your coding buddies. That will mean a lot. We'll be back again. Thank you very much to everyone who subscribed and supported tapaScript so far. It's all because of you. Thank you very much.